Hi everyone, here's Simone from Base Studio and welcome to this new video. This time I want to showcase a set of tools I made for my Patreons. There is one tool which is free and is the refined unwrapper. We are at the third iteration of the talks and it's doing basically what was always doing but better. So we can plug inside any shop. In this case I have a 3D model that, if you don't know, if you lock a model you save, this guy become part of the project. So he's this guy. You plug it in and this guy has three top output and one shop output. The first one gives us the point in texture, not the vertices, the points. Okay. Then we can have the normals, and we can also have the EV coordinate of the object. The third is the SOP, and why we are passing this one? Because we are adding some custom attribute so to make the unwrapper working. The unwrapper is basically a custom gel material which is using the images buffers from the render, so to avoid the conversion to chop and give us the texture at runtime mostly. It's not properly runtimes because you need to pass some custom attribute. This can hang up a bit the things if your model is very big, but maybe you do it before and then it's at runtime. So what's happening here? Basically we are we have a set of point which is a straight line, and the point we know they are a point in space, and x, y, z can be represented as RGB fair. Okay, this is 1 pixel, and we have a pixel 0, a pixel 100, maybe pixel 1, whatever. Then this is a straight line of point, 100. How many point we need? We have to split this line in a square. How you gonna do it? Okay, square root. The square root of 100 is 10. Oops, is 10 because 10 by 10 give 100. Magical math. Meaning that if I, let's say, break this one here and I say that from here to here they are 10, and then I take 10 here, all those tiny squares, this guy, we have 100 of them in this square space that is representing the line. So 1 dimension, 2 dimension, square root, very good. Nice, we have the point in texture, we happy, very good. This is free, link in the video description, have fun, do whatever you like. I am then sharing something Patreon only that are the advanced geometry tools that are powered by this technique. This geometry tool allows us to deform in real-time geometry in the 3D space via using some geometry effectors. The geometry effectors are made as a geometry comp, and inside they have some stuff. This should not be here. We have some stuff. I made a video where I use the point weight from the palette. I'm making some like particle floating around, and this guy, okay, it's coming from here, point weight, okay. And if you see, to do the deformation, I'm using a point transformer, which it pretends to transform the point to the given position that I can specify in the effect parameters somewhere here, and then you have a multiplier, let's say a threshold value. No, it's not threshold, it's a ratio, let's say a mapping factor, from 0 to 1, which is what's giving this texture. This texture is another jealous cell given from the derivative, which is like giving us the distance from a point to any point in texture we pass through this jealous cell. Okay, so how far is a point from all of these points? More white is more near, more black is far. So in this gray part we have the distance, which I believe is normalized, that goes inside here. Okay. To actually visualize the effectors, I am using a geometry comp with a sphere, basically, and if you then pack the geometry effect in another geo, you can render the effector so to see what you're doing. When you are happy with the deformation, you can close the effectors by disabling the display flag, and you have it not in top, but you have it in the geometry viewer. And the geometry viewer is pretty cool because we can do this. Let's I don't know, stop this one when it's near, like now. If you don't know, you can move stuff here, like in Edit 3D software. It's a bit hidden feature. If you click here, then you can move stuff around here. Well, look at that. Okay, so may need to reset some stuff. Yeah, there is a feedback going on, so maybe sometimes you need to reset it. But if you see now, theoretically, this should move. Yeah, you see. Now I select both of them. Maybe I just need to select one. Okay. You see, this should go back to perspective view. Here. Yeah, it's a bit tricky to use the geometry viewer, but yeah, this is what you can do actually. Okay, you see, you have physical real-time deformer. Bene, very good. Here you have, so this guy is the example, and here you have the tool that I used to build. There is the magical 2D VAT stay for vertex animated texture. So this guy, I teach how to build it in the Unwrapper Geometry series, which I encourage you to follow. It's in my YouTube page somewhere, and you can also buy it if you want in my Patreon. There is a discount code. You get it for half price. So, but this is basically reading the point instead to read it from here. It's not doing much. Yeah. There is a thing to say. Normal are not recalculated here. We should add the displacement somehow here, but for now it's okay. Next iteration will be better. Okay, then a bit of fun. Elastic engine, yay! A bit of fun with elastic forces. Hey, how are you? So also this one is interactive, and we have the effector and the elastic engine. It's elastic. Okay. So let's get this on side and go inside the elastic demo. Elastic demo is this. Now you see I am building the thingy here, copy shop, adding the attribute, yeah, because we need to get the attribute, and then there's the unwrapper, and we have a deformer, and the deformer is passed by the elastic engine. Okay, the deformer we already looked before. The elastic engine is this. Okay, we have Paqueta style, so in top, and this is in Jerusalem, which is very simple. It's a spring force. Basically, you have if you pull me one, if you pull something through you with a force of 1, this guy will go back to a rest position with a force a bit less than 1. And then when this guy is back, it remembers that you pull it, so you go back again, but with less, let's say 0.7, okay? And then you stay in the rest position, okay? Also, this one needs a bit of refactoring, but it's working pretty good. Have fun. So here is also a bit nicer to see. You see that this guy is deforming, is kind of rotating the geometry a bit. Okay? You have control, of course, over how much we rotate stuff. Here you see. Okay, so this is rotating on X, this is rotating on Y, which is, I don't know, not very cool to see, and this is rotating by Z. Okay, boing boing. And yeah, then you have the fall off, so this sphere has more power in the middle and a bit less in the edges. Give this smooth interaction. And this is already given from the point weight. I invent nothing, I just use it. Very good. Yeah, of course, we have the interactive geometry viewer. Pew. Yeah, can I click? Yes. Okay, yeah, you see, we are. Actually, I'm moving the other things, but anyway, you got the idea. Another really cool things you can do with the combination of 1, 2, 3, and 4, you can have this guy. Okay, and this guy is a kind of, I don't know, cloth thingy. Actually, to be cloth needs constraint, and this is not really constraint right now. But it's pretty fun to play, you see. Here this wobbly thingy. Okay, here we have a bonus, since the normal are recalculated. What the hell? Yeah, the normal are recalculated. So the normal are recalculated here. This is why you get this nice 3D effect, because yeah, the whole scene is a 3D scene. So yeah. Basically, if you could do it right here, but this is visually appealing to me. So the derivative, I don't know which iteration of Touch Designer was added, but they have this Z scale, which is very handy. And if you set RGB average, basically you get a good gradient for the normal. Yeah, which we are basically then using like kind of Gaussian step thingy here, so to make it seem nice. But you see, if I increase it, this is also nice. I mean, we have less, here we have a bit of grain as well, so we have more smooth, less smooth normals with a blur, which is handy. And then yeah, there are some trickery here and there, and like if you take from the normal here, you take the high map, and then with the channel mix you just take the alpha, because then you make a texture with the high map, and this side map you use it yeah, as roughness. When you pull it become nice. Yeah, you can explore yourself. There's also here, yeah, here is where there's all this pipe to to see how to work with textures. So if you don't have, if you have like a model with no data, basically, you can build it yourself. Here you see the edge is acting as ambient occlusion thingy. So in each cut we have here, I am adding a black part that if I make it white, you see, it is making some difference. So this is flat and this is like, you see, here, where you have basically edges, and usually you have edges in the UV when you have seams that can be used to split the normals here and there and cut them. You can, yeah, you have control over them. It's very nice. Bene, okay, then another one I build to showcase the geometry scanner. Okay, also here bonus, normal are calculated in GPU, basically doing the facets of GPU with the geometry shader, and using the effector, which is this one, which is the same, okay, but I'm not outputting the manipulating point, I'm just outputting the texture itself. This texture is then used as alpha of our RGB point, because this guy is giving back yeah, I mean, you have no alpha here, or if you have one, then you can bypass it. And you can, I mean, no, yeah, you have alpha is one. But I can change it with a reorder and take the alpha from the effector. So I encode a fourth value in our vector, which is going in the render pipeline, and I can use it. Okay, I can use it inside this geometry sampler operator, which is the shader I was showing you before, but with some extras. This is a bit technical, but the output, we have stages, okay? First stage, second stage, screen, basically, pixels, okay? In between here we have other stuff, we have no access, sadly. I would love to have access to tessellation, then you can do disaster. But we can act on these three stages by writing shaders. Okay, this is basically what the derivative gives by default. I just yeah, I'm sampling the point. You know what I said before, the texture, and so I'm not reading the point from here, I'm reading that from the texture. But okay, I'm also putting a value. Okay, so you have an out vertex, which is an input vector of the next stage, an input I don't know, bindings, I don't know how they call it, they are a vector anyway, which can represent like, I don't know, this look like a struct. Okay, anyway, they are used to communicate among stages, and with the float, this is extra, I add it, which is the alpha. Okay, so from the vertex, I then let the GPU doing some stuff for me, and I can read the attribute in the other stage, which is the geometry stage. And in the geometry stage, I can read with in, okay, and I read the draw. Here we're doing the facet. And if someone can help you understand why I need to do a module to have this value correct, I mean, it's a for loop, I don't get it. And then since this is a PBR, we have a matrix for the normals for the time, because you are encoding everything in a matrix with tangent and whatever. But the second part of this matrix is are the normals. So we can replace them with the facet, because if you move a point, you should update the normal as well, because if the point moves, the normal should be really stay perpendicular. And then we are emitting the primitive after the selection, only if I vert draw, and I need to I vert I because I'm looping all the point of the primitive, and I read the interpolated attribute I pass from the vertex shader, and I arrive here. This is the part, okay, which is make us emitting this geometry based on where is the effector. Okay, yeah, this is not one-on-one because I move the point a bit, but yeah, whatever. Okay, this guy is made with these two. And then you have this one. You have the geometry sprayer. You can draw geometry, which is pretty cool. You can make big eyes, and then you can make some big ears. Like this. It's cute. And a big nose, like a pig. Okay, TD pig. You just draw a TD pig, cow, tiny animals, which can delete. And this guy is basically the same stuff I just show you, but with a physical interaction made via feedback, which is telling where should we draw, basically, and sprite the geometry. The geometry are pre-calculated because we are putting out a grid. Okay. This is actually very nice because instead of draw you could yeah, you could actually just take a circle, for example, make this guy 32-bit, and yeah, if I plug it here, yeah, see, bam, yeah, you have a circle, which, yeah, the resolution should match the render in order to be squared, but I can just show you. If you then smooth it, you have I don't know, normals are acting a bit better, and yeah, Pac-Man, very nice. So yeah, and basically the shape got remapped for the point, and then it's fine for the alpha, so the texture and the point are matched, and you don't need to care much. All right. Last, as simple as it can get, I made an emitter. So yeah, you can move the 3D object, and the 3D object is basically a light because I pair it with a light. There is more I want to do here, because there's more I want to do here because I'll show you this, which is super cool to me. And yeah, we will add some stuff, and I post something on Instagram. The link is in the video description where I showcase the usage of this meshificator. And basically, yeah, look, mama, no render, and this with the pipeline of the emitter can be really fun. Okay, this will be posted after I close this recording in my Patreon as well, so you're more than welcome to come and get whatever you like from there. Just drop some money, guys. I'm poor. Ciao.